Thanks for joining, Dr. Hanson. Appreciate you taking the time. I think we're going to dig into some questions relating to UAPs and some of the work that you've done. Really interesting subject matter. Just to kind of sort of start off, be really appreciative if you could sort of run through kind of the core logic behind how you construct the Grabby Aliens model, kind of the key parameters, kind of the resulting predictions that have come out of that model. And then related sort of exploratory hypothesis that you put forward called the Panspermia siblings hypothesis, and kind of the motivation for that. And then kind of a key question that I have about that Panspermia hypothesis is you've mentioned in previous interviews that you formed a prior of about 1 in 1,000 for that hypothesis. So I'm really curious to see sort of how you got to that number, and we can kind of go from there. But just sort of starting with Grabby Aliens and then kind of rolling into the Panspermia hypothesis.
You asked me to talk about a lot of stuff here, so you should, I mean, I'll say things and you can interrupt and pause, to ask your clarifying question. Otherwise, I'll just go on with a long speech here, which you might not.
Please do.
So the key question is, where are the aliens? That is, we're here and we look out in space and we don't see anything out there that is not only like us or like what we might expect to be in a million years. And so that's this, old question, Fermi's question, where is everybody? And I previously, back in 98, or earlier, wrote about the idea of the great filter, just reframing that question as there must be a lot of difficult steps that life has to go through to go from simple dead matter to get all the way to where we are, to where we might become in a million years. And that clearly almost nothing gets through all those steps. If everything starts out roughly as simple as matter, hardly anything ever gets all the way to the end because, look, we don't see anything. But the question is, okay, but just how rare are aliens? They're clearly not a dime a dozen, but, we'd like to know more. And so our Grabby Aliens analysis is giving a numerical estimate of how rare they are. And therefore, that tells us roughly when we would meet them if we were to go out and become like them. And so the key thing is we're talking about the kinds of aliens that would be really big and obvious if you saw them. That's the subject matter here. I call those loud in general, and Grabby would be the name for the specific model. That would be in contrast to quiet aliens who aren't very visible, don't do very much, maybe don't last very long. And that's much harder to constrain by our observations. But we can talk a bit about some constraints we can have on the quiet once we have a handle on the loud ones. So the loud are big and obvious. So they appear at some point in space-time that is, some planet or whatever started with life. It went through stages. Eventually it had a stage, say, equivalent to ours, and then went onward to be even bigger and louder. And then at some point it started to expand. And in the simplest model, it just kept expanding, and it expanded at some speed. And then the model of the universe is that these things appear at random places, and then they appear at random times, except according to a power law we can talk about. And then they expand at a speed. And so the model only has 3 parameters. It has how fast do they expand, and it has 2 parameters about how they appear in time. One is the power of this power law, and the other is a constant in front of the power law. And our claim in our analysis is that each of these parameters we can get from data. Not only that, you kind of need to believe this whole model to explain why we're crazy early in the history of the universe. So at the moment, it's roughly 14 million years, which you might think was a nice old date, but majority of stars will last for trillions of years. And a simple model of when advanced life should appear would be toward the end of a star's lifetime. So overwhelmingly, stuff like us should appear trillions of years in the future, except we're appearing early now. And we say the analysis that says we should appear way in the future is assuming the universe would sit and wait empty for whenever we'd appear. And if the universe is empty, that would be right. And so our claim is that's not right. The universe is not going to sit and wait empty. The date on the clock is the key date. I'm telling you right now out there are aliens who probably have filled half the universe right now. Half of the universe right now is full of alien civilizations where not only have they, expanded there, they've changed things in visible ways. So the definition of a Grabby alien civilization is it appears, it grows, and then the key point is it changes stuff it touches. And we don't care exactly how it changes it. The key point is you'd notice. If you're looking at one of those, you would see it different from all the other space around. And so, again, the key story is we've got this model of Grabby aliens. Not all aliens are Grabby, but some would be. They would be really obvious. Then we can confront that with observations because they'd be really obvious. We have 3 key parameters in the model. We can fit each of those to 3 key data points we have, and therefore we have a rough estimate of the 3 parameters in the model, therefore where they are in space-time. And the answer is they appear roughly once per million galaxies. And we are roughly in the middle of the distribution of when they appear in time. And the power of the power law is, say, roughly 6. And they expand at half the speed of light, really fast, roughly. And if we do that, we'll probably do that within, say, 1 million years. And then we would expand out, and eventually we meet them in roughly 1 billion years. And those are the key numbers. That's the Grabby Aliens model. And so it says aliens are really out there in the observable universe. There's thousands of alien civilizations. Roughly half the universe right now is full of them. But where we are, we can't see them because there's a selection effect. When we look backwards in time out into space, we don't see them because if we did see them, they'd be here now instead of us. We could only appear now because our part of the universe is not occupied by Grabby aliens who grab and change things. And that's why we could appear now, and that's why around here things look empty. So that's a quick summary of the Grabby aliens model.
Excellent, thank you. And in that parallel relationship, the constant is our arrival time, and the exponent is the hard steps. So the estimate between 3 and 12 right. with a median of roughly 6. Is that what you got? So
the constant of the power law comes from our date. The power comes from our history of life on Earth, which suggests roughly how many steps there were. And the speed of expansion comes from the fact that when we look out there, we don't see anything. If they would expand slowly, then we would see a lot. We don't. Therefore, they can't be expanding slowly.
And what assumptions are you making about kind of this constant rate of expansion of the universe on cosmological scales? So in the conformal structure of the observable universe, you're assuming that... Right.
So we're assuming it's a local expansion speed. Mm-hmm. That is, you are expanding at a speed relative to local materials. You whiz past local galaxies, say. So the speed is relative to where you are and what's going on. So it's not a momentum trajectory speed. If you had just launched something and it just glided, then as the universe expands, its gliding would have it slow down relative to the universe. It doesn't have to hit anything. That's not slowing down because it's bumping into gas or something. It would just slow down because it would be going to a place in the universe where stuff was already heading in that direction at that speed relative to the origin. And then from that point of view, it's not moving so fast. So the idea is that that's not how it happens. It's not like some origin explosion threw things out and they just kept gliding for billions of years. That is, they send out colonists, ships, say, who go for a little while and land and start growing and building stuff, then send out more colonist ships, etc. And so that kind of process would be tied to the local materials at which you landed. If you landed at a star, you would be growing and moving with the star as it moved along, and then you'd launch out from that star, and therefore you'd inherit the speed of the stuff that you landed on.
Excellent. I have a question I want to come back to in terms of the relationships between what we think is maximal understanding of physics and sort of maximal possible technology that could be sort of where that hard scrabble frontier of technology development lies and that expanding civilizational kind of surface volume. I want to come back to that because I want to link in, part of the speculative hypothesis relating to panspermia, because I think this is where kind of these two key questions kind of come into intersection. So you've done some work for a number of years looking at the question of panspermia kind of separate from kind of the UAP conversation, just as a pure sort of astrobiological question of how plausible is that as a hypothesis for the emergence of life on Earth, and then as the emergence of life in in other sort of regions of our galaxy that might have suitable conditions of stellar nurseries exchanging material, as raising kind of your prior probability, ascribing a credence to the possibility that life evolved earlier than Earth and arrived on Earth as a result of that sort of panspermia.
So let me just do some throat clearing. So the Grabby Aliens analysis I described, you can go to the website grabbyaliens.com and see the paper and some videos and things like that and interviews. That was published in Astrophysical Journal. That was a group effort. And that's a mathematical analysis of where aliens are in space-time. Then in parallel with that, people were talking about UFOs. And I said, hey, I have an expertise in some related thing here. Why don't I think about that? And so I've thought about that and written it up in a less formal way, and it's less mathematical. But I still think it's solid to the extent that I'm being clear about what I'm saying. So I would say if the basic problem of UFOs is that there's a phenomena and you're trying to explain the phenomena. So in a Bayesian sense, there's two kinds of things you want to have there. You want to have a prior and a likelihood. The likelihood is for any given theory, how likely is that thing you saw to happen given that theory? And a prior is just how likely is that theory ignoring anything you might have seen? And then you combine those things to get your probability distribution in the end over the different theories you have. So that's the task of thinking about anything really, including UFOs. And in that area, I'm not expert on the likelihood. That is, on looking at the particular reports and how they played out and exactly how plausible that is given various theories. But I do have an expertise, given my Grabby Aliens work and other things, on the prior. That is, what kind of hypotheses could we invent here? And then how plausible are they? That is, I'm an economist who also knows a lot of physics and astrophysics. And so I'm well suited to think about these different scenarios and how believable they are. So that's where I'm coming in here on this topic. And so if we were to say UFOs, we have roughly 4 categories of explanation. They could be just accidents and delusions. There's just nothing going on there. People are just misreporting. There could be some sort of secret organizations that are on Earth that are making things that have abilities they haven't admitted to, but they just have much more capability than they admit to. And so these things are real, but they're from some Earth organization. Another explanation is that they are fakes or hoaxes. There's some Earth organization that's making people lie and faking things to convince people there are things like this. And the fourth explanation is these are real and they're not from Earth, they're from elsewhere. And I can speak to all of these priors, but obviously the one that people are most interested in is the prior about aliens. And so I could say, what's the prior there? So the task of a prior is to come up with a story for how something could be or true. That's the most likely story you can find, the most plausible. But any story you construct is going to have some elements that you invoke, and each of those penalizes that scenario in terms of a prior. That is, you're kind of multiplying a bunch of terms, each of which is penalizing the scenario, saying, well, you had to make this thing up. How believable is that? And the more unbelievable is the thing you had to make up to make the story work, the lower the prior on that story is going to be. So here the question is, what's my best story to make up? And so the challenge here is, what if there really were aliens around here behind UFOs? What story could make sense of that? So my simple Grabby Aliens analysis says the nearest one is, a billion light years away. No, there just aren't any aliens around here. Full stop. Forget it. But if I think about it, I go, well, let's modify the model and maybe we can get closer. So the key thing we need is a correlation. They appear roughly once per million galaxies. That's really far away on average. But if a bunch of them appear together at the same time and place, well, now there could be a few near us, even if almost everything else for a million galaxies away is empty. So how could we create this correlation where a bunch are created all at once? Well, panspermia is exactly a mechanism that could create such a correlation. And panspermia has been talked about, for a long time in the astrophysics literature. So the idea is life started on a planet, not Earth. And that life went through some, development over billions of years. And then at some point, some rock smashed into that planet, knocked off another rock from the planet that had life in it. That rock drifted for maybe millions of years. And then it landed somewhere else and seeded something else with life. And that would be panspermia. But the most plausible time at which panspermia might have happened to Earth would have been at the very beginning of Earth's history. And at the very beginning of Earth's history, we were in a nursery where thousands of stars were born all in the same space and time and place, each of which has many planets. And so if a panspermia had seeded Earth with life at that time, it quite plausibly would have also seeded many other planets in that same nursery at the same time. And they would be our panspermia siblings. So far, what I need to, in my hypothesis, is that panspermia is true, first of all. Life started in one place and then spread somewhere else. Maybe I'll give that, 1 in 10 or something as a plausible story. But it seeded a nursery, maybe a 50-50, 1 in 2. That's pretty likely. It seeded multiple places in the nursery. And then now we've got the scenario where life is evolving on multiple planets, maybe hundreds in this nursery. We know that they then spread out across the galaxy. They drift apart from the nursery. Right now they're in a ring around the galaxy, all spread out after 4 billion years. And now they all go along this path of advancing life. And then one of them reaches an advanced level first. And then the next key assumption I need, it wasn't us first. Maybe I add another factor 2 in for that. It wasn't us first. Somebody else was first. Okay. Now, the story isn't done, right? But we have so far produced aliens near us, right? Now, the timing here, almost certainly, it wouldn't have arrived at our level in the last 100 years or 1,000 years. It would, even million years would be quite unlikely. So the average duration we would expect is maybe 100 million years. So they appeared at our level 100 million years ago. That's the scenario we have. And now we're not done yet, right? We have to create a scenario by which, and then they come here, and then they do the weird stuff they do, and they don't do all the other stuff they could have done. That's what we need to add to the scenario. So that last part is crucial. If you think about it, look, they appeared in our galaxy 100 million years ago. That was plenty of time to go wild, redecorating, restructuring not only our galaxies, but the nearest 1,000. And they didn't. That's what the scenario has to explain, right? That's one of the things. Why, if they appeared near us 100 million years ago, they didn't go wild, expanding and becoming Grabby. So we have to postulate. I think, again, a factor of 2 is plenty, though, to cover this, because I think, in fact, maybe most advanced civilizations choose not to become Grabby or don't do it. And so they chose not to become Grabby, but that requires a civilization-wide policy against it. That is, if any one small part of their civilization decides to go become Grabby, then Grabby happens. So the only way a whole large civilization could not become Grabby is because they have a policy against it that they enforce successfully for 100 million years. So that's another part of the scenario we have. That's their policy. But once we have that, now we kind of get for free why they'd be here. That is, they have this policy against expansion. They have to realize they have siblings. They know there's these siblings out there. They'd be watching them in telescopes and tracking them. But they would know that if any of their siblings decided to expand, that would be the end of their policy against expansion. So that's plausibly why they'd be here, to convince us not to expand. And another thing we can easily postulate, I think it doesn't cost much in the prior, is that they would rather not just kill us. Because clearly they'd have the ability to have done that. That would solve their problem. And they could have easily done that by now, and they haven't. So obviously they don't want to. Now, That doesn't mean they won't later, but they would rather persuade us and have us do this voluntarily rather than destroying us to solve this problem. So far, again, we postulated panspermia is true. It seeded a nursery. It seeded several stars of the nursery. One of them became advanced before us, and it chose not to expand. And those are the key things we needed to assume so far. But we've got one more part of the scenario to explain, and then we're done. But I think, so far we're doing pretty well in terms of the prior. The last thing we need to explain is, why are they hanging out at the edge of visibility? Because they could have had the two other obvious choices. They could have been completely invisible, which 100 million years more advanced than us would be just trivial to do. Or they could be completely visible. They could, show up on the White House lawn, as they say, and wave and talk and do demonstrations, and then it would be just really clear. So they didn't do either of those things, according to UFOs as aliens. That is, these reports of UFOs, and what if they were aliens? Well, these UFOs are visible. They're not completely invisible, but they're not completely visible either. They're at this intermediate stage. What's with that? So we need to invoke one last part of the hypothesis to make the whole story work, which is why they in the middle. So the story is, when we humans have domesticated other animals, the way we've done that is by slipping into the top of their status hierarchy and saying we're the top of their status hierarchy. They should do what we say. That's how it's worked. And we humans have domesticated each other that way often. An emperor slips into the top of our status hierarchy and says that they rule us. So if they are social animals, that would have happened to them in their world too. They would see robustly that social animals have a status hierarchy, and you can persuade social animals to do stuff by being the top status animal in their group. That's how we domesticate other animals. So then the story would be, their plan is to persuade us by that strategy. They're just going to be very visibly impressive and persuade us that they are the top dog around, and we can already infer their agenda, and therefore we would go along with it once we accepted them as the top of our status hierarchy. So to make that work, they need to be here and peaceful. They can't be like far away or threatening us. So they have to act pretty peacefully, but still, show their amazing abilities. But there's also a risk that something about them would put us off. They're aliens, remember, right? So just think about all the different ways humans have resisted other foreign cultures and not accepted them as the dominant animals in their pack. Humans are very sensitive about even relatively small cultural differences. So they realized they needed to not reveal very much about themselves to avoid this risk that something about them we'd hate. Maybe they eat babies or something. We don't know. For them, that's not a big deal, but for us, it might be, right? So their strategy then is to be really impressive, to be clearly visible, to be peaceful, and to not show us much else. Not give us a chance to go crazy about something else about them that we would hate. Then that's the story. So now I would say a 1 in 1,000 prior isn't crazy for that set of assumptions I needed to make that story together.
Excellent. So I have one question on the, thinking through, the sort of alien sociology that we think they've sort of instantiated as part of this, SOP for these really restrictive contact methodologies that, limited elements of the civilization are permissioned to engage in. Anthropological literature is familiar with the concept of cargo cults, right? Where a less advanced civilization, perceives an advanced civilization's technology as almost a godlike or sort of mythological, and actually that stimulates sort of ritual like replications or attempts to replicate what they see as advanced technology. The World War II stories of building the. So is there a risk in this sort of signaling social dominance strategy that it might actually, instead of suppressing our desire to expand, it might actually instigate our desire to replicate their technology and desire to expand into the cosmos and be like those alien gods that seem to have this advanced technology? And if that's a risk that sort of pushes us along this trajectory of expansion before we get to the point where we sort of cotton on to the fact that actually, wait, they're here to enforce this rule, that those things may not actually happen at the same time, and we sort of bump up against their constraint before we realize that it's there, and now they have to make this choice to either sort of knock us back down or become much more overt in signaling. So how do you factor that sort of sociological reasoning that may or may not be part of that sort of SOP?
So we can think of social technologies advancing and sort of physical technologies advancing. And in our civilization, we won't be capable of interstellar colonization for quite a while. And we already have really quite advanced social technologies in the sense of being able to discuss these things and analyze them and have experts who do those sorts of things. Mm-hmm. So in our civilization, they would be right that there's not that much of a risk of encouraging the expansion here and a much bigger chance of convincing us not to, because we are capable of reasoning about not expanding and that they may want to. So what you might say is, well, how sure could they have been that this would have been the order in which these two kinds of technologies would appear? Mm-hmm. You could say, what if a primitive tech civilization with very crude religious reasoning or something could have created starships? Mm-hmm. In that case, then there's the risk that they haven't thought through, what they've learned from these aliens while they, are eager to just copy what they see. So, I mean, I have to say, if you're trying to imagine alternative histories into which that's possible in our world, I just really can't come up with that. That is, mm-hmm. Starships are pretty hard. They require a lot of organization and a lot of knowledge. Mm-hmm. And it's just not very plausible that you could have been capable of that and ready to use that and yet somehow not be able to do the most basic reasoning here about who they are and what they're doing and what their point is.
Got it.
And of course, in that scenario, they could say, well, okay, those people, we're going to push the button and that's going to be the end of them. Yeah. And we're going to lose out on those. Because remember, they almost surely have some sort of fail-safe ready, right? Mm-hmm. They want to persuade us, but if they don't, they have another option. And they would, be sad to have to use it perhaps. But, the scenario you're invoking here is a pretty perhaps unlikely scenario, and maybe a scenario which they aren't so sad about that. Like if you've got people with starships with that poor level of sort of social understanding and reasoning heading out there, maybe you don't want those people going out there. Maybe that is the right thing to do.
Yeah, I'll put a pin in that question. I'm not sure how mature our social technology is at this point.
But it's much more than some other counterfactuals we can imagine. Certainly.
But on this very question, you mentioned kind of, we're reasoning through the scenario and sort of the principle, if not the sole objective thus far described for their presence here is to enforce this rule against becoming grabby. Could there be an ancillary objective, hard to see where it would go in the priority order, of studying us as one of the few civilizations they're likely to be in the presence of before they know, because they're probably going to run a version of your Grabby Aliens model in a billion, roughly years, they're going to contact. And so they would want to benefit from, studying us and trying to glean insights for how other civilizations evolve and mature. And so they wouldn't necessarily just have this sort of simple procedure of enforcing non-grabbiness. They'd want to study us to a certain extent to gather empirical insights that would help them civilizationally prepare for this, inevitable but still distant contact with the Grabby alien civilization. And how do you think that would factor into their decision to have this sort of binary, fail-safe, right? Would they still want to, how strict of a rule that is that rule truly going to be when there's, empirical value in observing us and seeing how our civilization matures as being a relatively small candidate sort of sample available to them?
I don't think you need to make very strong assumptions to postulate curiosity. Mm-hmm. About another alien civilization. So I think certainly all else equal, they would like to learn more. The question is just how much are they willing to suffer or risk to get that? Again, we're imagining a civilization that for 100 million years has successfully enforced a strict prohibition on any part of it expanding. that can't happen without a lot of pretty anal attention to that goal. This is not a sort of whim. This is not a maybe it's kind of nice sort of thing. It had to be a very strictly, severely, consistently enforced rule to make it actually work. So that tells you their priority level on that, and that it's pretty clearly going to be a higher priority than their curiosity. I mean, maybe the simplest thing they could do is just like maybe flash freeze us and then put us all in a simulation and then turn it on and then see how we evolve from there. That might tell them most of what they wanted to know about where we would go without taking the risks, right?
Yeah. So related to that, I'm really curious to try to explore in this scenario what we can infer, with some degrees of uncertainty about other things, given the fact that they're apparently been able to enforce this rule for as long as they have, and have presumably maxed out, and that this has been an implied premise in some of the discussion, is that at a certain level of technology development, you sort of reach a maximal level of technology, right? That sort of is somewhat implied in this discussion, is that the rules of physics, such as we think the universe is constructed, I'll sort of put a ceiling on the amount of technology that's feasible. So once you reach a certain level of maximal understanding of physics, you have now reached sort of a maximal possible technology that allows you sort of to exploit the sort of degrees of freedom available to you in the universe, sort of whatever, technology, writ large that is now available to you as a civilization. So the fact that they've been able to both enforce this rule effectively over 100 million years and, by assumption, have reached maximal level of technology, what do you think that implies about that maximal limit of technology? What does it not allow them to do, right? If it just allowed instantaneous teleportation, right, by like anyone at any time, that would seem to be, a thing that would really hard to enforce, right? So just say like things that you think can be inferred from that as a scenario.
Well, first of all, the whole scenario is going to require that even though civilizations have billions of years of history of development, they still can't escape some key physical constraints. Say the speed of light is still a constraint on them. If you weren't willing to assume that constraint would apply, then the whole scenario doesn't make sense. And if it was possible to say, expanded faster than the speed of light, that basically means any civilization anywhere in space-time could fill all of space-time. And it makes the Fermi paradox much more difficult. Why is it that we see anything in space-time anywhere empty if, once you advance far enough, you can then travel faster than light and go everywhere in space-time? So it seems like we need to assume that that's a hard limit. And of course, as you indicate, we have to assume that it's actually possible to enforce such a rule. Now, we can already think of many ways to enforce it that are not very pleasant and at high cost. The question is just how low the cost can be. I mean, clearly, say, for example, if you, prevent any further technological development from where we are now, then, you prevent a lot of, just this, nobody in the civilization can reach interstellar colonization abilities. They'll then, you've successfully enforced the rule. But that's not consistent with them having these particular visitors here. So in order for UFOs to be here now, and yet them not to have expanded, we need them to have the physical ability to travel here without it being used by the rest of civilization. But that could be maybe drastically limiting the technology of the rest of civilization and only allowing a small exceptional group to even have this technology, to even work it out and invent it. But the key point is the speed of light has to be an actual limitation. And of course, they'd have to, looking at the actual materials in our universe, they'd have to find that, actually useful.
Is it actually, is it a safe assumption I may have snuck in to claim that such a civilization that's been around for a long time would have maxed out possible technology, right? By some of the analysis I've seen you give that, leads to the sort of civilizational stasis, right? That at a certain point, the civilization reaches the level where they decide this is a rule they want to enforce. and they will enforce it with whatever technology is available to them at the time to make it maximally effective. And so the threshold that they just need to clear to enforce that rule isn't the maximally possible technology available to them in the universe, but just the maximally effective technology to allow them to enforce that rule. There might be like a further level of technological capability that they just never got to because they sort of locked themselves down and sort of froze their level of technology development at that point. And so is it fair to, I guess how do you react to that? Is that a fair sort of assumption there that there could be space of possible technology that they just decided or weren't able to explore?
So we're talking about the space of quiet alien civilizations, not the space of grabby ones, right? So the grabby ones are spread out over an enormous area with lots of different parts expanding rapidly. That seems more robustly that they would just achieve whatever is possible with lots of technological innovation and development. But the quiet ones can have a wide range of possible histories because we can assume that they can be more coherent. They can have a strong central governance of some sort that then makes choices about which kinds of things get developed or done or which don't. That sort of gives you this large space of possibilities for them. And I don't have a good way to restrict in that space what could or couldn't happen. So, obviously in this sort of thing, what we have to be the most careful about doing is methodically making only the assumptions we need to, the weakest assumptions we can think of to do whatever we're trying to do, because we're talking about pretty, big things that we know a minimal amount about here, right? So that's what we're trying to do, is just make the smallest set of assumptions we can and see how far we can get.
So yeah, of course, right? We're pretty far down the branch of the Bayesian tree. Sort of dialing it back a bit to sort of what do we think, or how do you evaluate evidence? One, to sort of motivate the prior, right, which I think you've walked through, and you said, I want to tell the sort of best possible story while making sort of the most sort of empirically grounded assumptions, right? But the motivation for telling a story sort of is just sort of triggered by like prima facie accepting certain authoritative pieces of evidence, right? Like the Navy videos, like there's something that we're trying to explain, right? Like we wouldn't bother coming up with such a story if there wasn't something that was apparently anomalous that we're trying to explain. And then we're coming up with what we think is the best explanation that, most sort of simply and consistently sort of epistemically sort of least onerous explanation for that. And so the things that you're trying to explain, like the sort of the set of things that the story is supposed to account for, is the sort of story of there being objects that display advanced sort of aerospace propulsion capabilities that can apparently travel in all sorts of ways that aircraft that we're familiar with can't do, that are behaving in certain ways. And so we're taking at least those reports at face value, right? We're not assuming there's sort of an underlying explanation that's favored necessarily. But are there other things like that, other reports or observations that go in that broader bucket that also need to be explained, and sort of how do you discount those, right? So for example, there's been persistent rumors, right? Again, this is like in the crust of taboo that surrounded this whole topic for decades, of there being crashes of these aircraft, right? There's been no proof of this, right? But it's been a persistent feature of this story of some anomalous phenomenon that there's been crashes, some physical engagement of human beings with this technology. That seems difficult to fit into this scenario, right? That seems difficult to explain if they have advanced technology and it's wouldn't just crash after being around for 100 million years, or at least not intentionally. So like, now that you've motivated such a story in order to account for a certain subset of these apparent phenomena, how do you, I guess, evaluate, in a provisional manner, these other aspects of that story that don't seem to be consistent?
So the way I think about this is to say people sometimes think in terms of the categories of the normal and the paranormal. And there are many normal phenomena that are widely accepted as just being real phenomena that people have to varying degrees integrated into our general picture of how the world works. And then there's a set of paranormal phenomena, which there are people who say they are real phenomena, and then there are many skeptics who don't buy that. And part of history has been things moving between those two categories. So, as centuries ago, asteroids were paranormal. The idea that rocks would fall from the sky was kind of silly. The sky is empty and pristine, and there aren't supposed to be rocks up there. And but then later we came to decide that was a real thing, and we integrated that in their world, and asteroids are no longer paranormal. In the last decades, there are these high-level lightning things that look like pink octopi that pilots reported a long time ago that were dismissed as silly. And then NASA, a few decades ago, took pictures high level and said, those things are real. And the pilot said, yeah, we stopped telling you about them because we thought you think we were crazy. But that moved from the paranormal into the normal. And then ball lightning is a, paranormal phenomenon, not taken very seriously. You actually look at the best evidence of ball lightning, it's not very persuasive. Nevertheless, people made it in the lab, and then they said, oh, I guess it must be real. Here's ball lightning, right? Those are things moving across the boundary. And if there are some other kinds of paranormal phenomena, like, I don't know, ghosts or fairies, and I'd say, okay, I tried to look at what the best evidence people have presented for ghosts or fairies were, and I go, I don't think that looks very good. I'm not very moved by that. I'm going to leave that over in the paranormal category in terms of my inclination. So I think given that there are all these paranormal things, it's a little too much to ask of any one person who says this particular paranormal thing has been mislabeled. It should be in the normal. Ask them to try to explain all the other paranormal. That's going to end up with nothing ever moving across the line, right?
Yeah.
I think it should be legitimate to pick one kind of paranormal thing and say, this has been mislabeled. There's something without having to do it for everything else. Right. And leaving the question open, of course, of what else might move across the line at some other point. But, and it's actually kind of a standard thing for contrarians in general. This is kind of an interesting thing to notice about contrarians in general, with which I am in some ways something. There's like usual views, and then there are contrary views on many topics. And each contrarian is really trying to say, we've been mislabeled. Our contrarian view is, yes, at the moment, not very popular, but later on, it's going to be the usual view, and then you're going to see it as the usual view. And don't lump us with all those other contrarians. That's what all the contrarians are trying to say. So there isn't actually a natural coalition of the contrarians. They're not going to convince everybody that all the contrarian views are right. That's just never going to happen. They're each trying to bid that their particular contrarian view deserves to be separated from the rest. That does seem like a reasonable intellectual strategy. Is not all the contrarian views will stay contrarian. Some of them will, in fact, be revised and decide to be not. But probably the majority of contrarian views will stay contrarian.
So I guess to put a fine point on it, you said your prior was roughly 1 in 1,000 for the panspermia hypothesis, which could be formulated as a proposition, the phenomenon that we refer to as, UAP, the phenomenon by which is motivating all this congressional activity, the stuff that the Defense Department has now been studying, that represents non-human technology of some kind, right? Maybe
it's crucially going to be a portion of it, right? Mm-hmm. So, there have apparently been 100,000 UFO reports over the decades, right? Whatever, even if you think some of them are aliens, you're not going to think all of them were, right?
No. Yeah.
You're going to think a bunch of the others were delusions and illusions and misreports and hoaxes.
Yeah.
The question is just, are some of them also aliens?
So what would you describe as now like your current posterior for the panspermia hypothesis as an explanation accounting for?
That would require me to fold in the likelihoods. And so I'm trying to declare that I'm trying to put on my hat as an expert and try to say the things I can say as an expert and then be careful about what other things I might say. I think, in fact, if I gave a number, people would attribute that to me as the expert and not as the just ordinary human who might have a human. So I think that I should not do that then.
Okay, so let me rephrase the question then in terms of just the relationship between two sets of priors, the prior with respect to the panspermia hypothesis and the prior with respect to a related hypothesis, which your prior should, I'm assuming, be correlated, right? So if your prior for UAPs represent non-human technology goes up, right, as a result of doing this empirical sort of storytelling, how much should the prior for UAP non-human technology is in the presence of some, or is in the possession of some, human institution, right? So like that's a proposition that people have different beliefs, that sort of, credences over, but I would assume that your prior for that proposition should be linked to your prior for the Panspermia hypothesis. That if you believe the prime, if your credence goes up for one, it should go up for the other. But the question is, how much are those connected?
If there are aliens out there at the periphery of our vision showing how powerful they are, in my story, that doesn't actually create a very high likelihood that they would somehow accidentally crash and spill working technology around that other people could pick up and figure out how to use. That doesn't really follow here. They would 100 million years more capable of us. They would not be accidentally dropping stuff. And if they were, we weren't going to be able to figure out how to use it. That just doesn't seem plausible to me. I'm not seeing a connection there. But I think what might be more interesting is they talk about one of the alternative hypothesis categories, in particular the hoax category. So the hoax category, I think, has a higher prior. I would give that more like a 1% prior. It's a prior that like some big organization like the U.S. military has had a long-term policy program to create a series of similar hoaxes, right? It can't just be a one-off hoax. We have to be talking about a large hoax program that's created a lot of hoaxes. Now, maybe other people copycatted that or, reported when they didn't see it, but we'd have to have a lot of these hoaxes. And there'd have to be a big program to do that. And I can imagine some reasons why they might, but still I got to go, well, it'd be an unusually large hoax compared to what they've done. There have been large hoaxes in the past, but not that many. It's the sort of hoax they could pull off. And it's like in many ways hoaxes they did pull off. So it's not crazy, but still it is kind of a weird kind of hoax to be pulling off, even if I can think of some reasons for it. So that's why I'm only going to give it a 1% prior. But now I'm going to say, well, look, that's a prior higher than my aliens prior. Now we really want to be paying attention to the data to ask which theory is the data most consistent with. But I would have to say, conditional on the hoax theory being true about UFOs, I'm going to have to worry about, say, the moon landings. I'm going to say, if they were willing to and able to pull off the UFO hoax, yeah, they might have faked the moon landings too. Then I'm going to have a higher prior on that one too, right? That I see more of a connection there.
Yeah, and I think there's a certain degree of overlap, right? Like between those two hypotheses, in the sense that if the UAP hypothesis is aliens was true, it's plausible that human institutions would find ways of using that fact to act as cover for other things they want to disguise, right? So you would want to use the fact that there's a social taboo around UFOs that is in the public imagination to distract adversaries potentially from your development and testing of an advanced sort of weapons.
I think we already do know that, say, the U.S. Defense Department has, in fact, used the idea of UFOs to, hide some of their more advanced development programs. That's, true. Yeah, that's different from a large fraction of UFO reports of the best sort being the result of such a hoax program. That's a different hypothesis. But clearly, they, on the margin, did opportunistically take advantage of that.
So going back to, I guess this is more of a maybe outside of your domain of expertise here, but I'd be curious to hear your perspective on, so if something like the Panspermia hypothesis was true, right, how would you advise, a U.S. government that was confronting that fact and had to develop a national strategy for that, right? They'd want to develop it somewhat covertly, because you probably wouldn't want to just come out and say, here's things flying around, we have zero idea what they're doing or why they're here. Good luck, everybody, right? So you'd want to have some way of communicating to the public, and you want to understand what are the risks associated with, the boundaries of that space of possible engagement or disengagement. And what would be your recommendation, or what would be at least the questions you would think such an agency should have to ask themselves if they're trying to formulate such a strategy?
So my PhD is in formal political theory. So the first framing that comes to mind is, what does a politician want to do to maximize votes? And therefore, what do they want to instruct their subordinates to do in order to support their political strategy. And here, if you believe that in fact UFOs are aliens and that they are just trying to convince us not to do interstellar expansion, but otherwise they're going to hang out at the edge of our vision, then if you don't think you could convince the public of that very well, then you just want to shut up about it and not talk about it. Because you want to wait for somebody else to do that. You say, well, there's no risk right now. We're pretty far from interstellar colonization, so we're not going to piss them off badly now. Later on, somebody else will have to deal with that. But politicians are quite adept at kicking cans down the road when they don't see a gain in picking up the can, right? So you might well think, given the state of public opinion here, they are well advised to ignore the whole thing and leave it off for someone else. And maybe that's what they've done.
Excellent. Yeah, I think that's very plausible, and that's maybe a plausible explanation for why we haven't seen much. So tabling the panspermia UAP as aliens question aside, I really want to go back to maybe some of the more intriguing philosophical implications of the Grabby Aliens model, right? So that, I think, is sort of epistemically is much firmer ground than the quiet aliens are here buzzing around sort of hypothesis. But we have reasonable empirical evidence that this is the story for the cosmological evolution that we're going to witness over the next several billion years. And if humanity has this desire to become one of those grand civilizations on cosmological scales, and we manage to avoid whatever non-grabby civ is here to trap us, if that's not a limitation, what is that like? And maybe you're doing some work now. I think maybe you referenced this might be the subject of some ongoing work. Like, how does that affect how human beings should retell the story of our cosmic quote unquote endowment, and what sorts of maybe novel motivational structures for a whole civilization, right, like would or could be constructed to either disfavor or favor that as this is now like the single biggest question for humanity. Should we expand or should we not expand? And what are the sort of determinants of that question? And how do you think that will assuming we're not trapped here, like how do you think that will actually play out?
So first of all, most civilizations have had cosmologies, which is sort of the largest scale of space and time, and stories on that scale. But usually the stories had agents who had goals and plans and personalities. And the cosmologies that we've been telling lately are cosmologies without much in the way of actors other than us, right? They just have a big empty dead universe that maybe we will go out and do something with, which isn't as inspiring a cosmology as a cosmology with grand gods and other things going on. So luckily, in some sense, this returns us to a perhaps more inspiring cosmology. There are all these alien civilizations out there right now. They've already filled half the universe. And they have agendas, and we can roughly guess what they are. And we will then, if we choose, go and interact with them and make a bid to join them in the pantheon of gods. And that might be a more interesting cosmology, more motivating cosmology. And that's the first thing to just say is, hey, the real cosmology as we see it is actually more interesting than you thought and more motivating. Maybe you could, but there's still a question of how to frame yourself in this cosmology. But at least there's a story going on with other actors and, with agendas and constraints. And that's a more interesting story that we're in now. But I would say the key choice will be whether to be quiet or loud. And you might think the choice is obvious. Of course you want to be loud, but I don't think it's so obvious. And I want to sort of communicate that to people. I mean, I think I might personally prefer we become loud, but I don't think my preference should be the thing that wins here. Mm-hmm. I want other people to really see the choices more emotionally and intuitively and get why this is a hard choice. And then help make it. So, this choice won't be made in my lifetime, unless I live a really long time. And, we will need to talk about this for a while and think together about our attitudes about this. But, so to present the other point of view, I would say, look, we humans grew up for 1,000,000 years as foragers. We lived in small bands of 20 to 50 people who shared a lot, who made communal decisions, who enforced the rules informally by deciding together what to do. And we liked that world. And deep inside us is really liking a world where the key decisions are made communally together about the biggest risks and issues we face. And then 10,000 years ago, the farming revolution changed society radically, and we broke into these different communities on larger scales that had more conflict. We had war, we had classes, we had religion, and we just lived as farmers for 10,000 years, somewhat at odds with our forager nature, but humans are plastic enough culturally to do that. And then in the last few centuries, we've gotten rich. And as we've gotten rich, we've allowed ourselves to drift back and indulge our forager child inside. And that's partly why we can say that the world has had more democracy, more leisure, less religion, less fertility, more art, less domination at work. There's just a whole bunch of trends that we can understand in terms of us going back more to forager ways. And one of those things is we just more want to make big decisions communally by discussing it together and deciding together what to do. And we have been doing that actually more. That is, we've had a great decline in the rate of war, and the world has created more of a world community of elites and others where many decisions are made pretty similar around the whole world, as we saw in, say, the pandemic. Elites everywhere do it pretty similarly, push their local places to do it similarly, in part because they're part of this world culture where they want to be respected by other people in the world. And so we are creating a world mob, if you like, a world community that does great many things together by talking about it all over the world together and deciding what to do. And again, that's how we did it in the pandemic. We had remarkable convergence of pandemic policy worldwide, and a sense that we were all in it together and deciding together what to do, and then doing it. And I think we will continue to move in that direction. We will probably get stronger world government, but even without stronger world government, we'll have the stronger sense of a world community where we all decide together, in a sense, what to do about big important problems. And then we will credit that to solving bigger problems like global warming or inequality or innovation and overfishing or whatever else it is. We will see that we have in part solved these problems via this shared global community where we not just decide what to do, but we also repress problems we don't like. So we push for regulations and we limit competition. We may even limit, say, population growth by limiting fertility rules and preventing evolution from making us into strange descendants. All of those things we might do by having a global community and global regulation that, pulls us back to our forager roots of deciding things together through peaceful conversation and social pressure to get us all to go along with whatever we decide by conversation. That's a future that we are achieving and we will continue to achieve. But then the moment interstellar colonization is possible, we will be smart enough to know that if we allow that to happen, that era is over. Once colonists go off far away and then they send more colonists off, then we return of fierce competition, return of strong evolution, and the inability to actually talk about everything and decide things together as a civilization. That will no longer be possible at that point. And people may well really like who they are and what they've become as a global civilization by being able to talk together and exert pressure on each other to do things together. And they might think, sure, we can be far more in number, but we'll become alien and betray our principles if we allow people to go out there and to become strange and to compete and war even. So, one of the biggest things that we are reducing is war via this sort of global coordination to suppress behavior that deviates from our shared agreement about what's the best. And that will continue, but once the colonists head out, war will return.
So one last question. I think we're heading up on time. And this is a little bit more speculative, but it kind of connects to what we think is the race condition between the development of that strong global coordination sort of social framework, and then the associated physics understanding, and then technology to break that social constraint, break that coordination system. And one assumption is that it's just going to be a long time until we get to that level of technology. So we have the time for those social structures to evolve and then mature, become effective enough to be able to enforce, their rules upon any new discovery that gets made. I just don't know how likely that is that this sort of chunkiness of technology growth relates to our exploration of the physics understanding space, right? And that has moved. We don't have a whole lot of sample sizes for understanding how physics progresses, right? Sort of first start with initial experiments in Aristotle, and then really took off in the last 100 years with quantum mechanics and general relativity, and we've been stalled for the past 50 years, say, with string theory, kind of at a dead end. But who's to say we unlock a new breakthrough, some completely sort of paradigm shifting conceptualization of fundamental physics that radically unlocks potential technology? So we had the discovery of quantum mechanics and general relativity, and then 20 years later or less, we had nuclear weapons, we had transistors, we had explosion of new technologies that were impossible to conceive of before that physics understanding was unlocked. So I guess how do you react to that as a more speculative claim that physics breakthroughs, we're sort of looking through, we're exploring the sort of dark space where sort of know the walls are somewhat bounded, but we don't know when we're going to find that third or fourth wall. And then we've now bounded the space of possible physics, and then we can try to maximally exploit that for technology. You could see a rapid takeoff. Is that really a million years from now? Or could that be 50 years from now, 100 years from now, or less?
I think in the next 1,000 years, we may well develop all the technology we're ever going to get. So it may not take a million years. It depends on how fast growth accelerates in the near future. But I think of if I'm basically willing to assume that our space and time won't fundamentally change. That is, we will be spread out across space and time, and we will need sources of a neg entropy, which is, a key robust feature of physics. And then neg entropy will be located in a space across time, and technologies will be things that take up space and use material, and that take a lot of neg entropy to construct. And sort of the more advanced a technology is in a physics sense, initially at least, the more neg entropy you would have and material you would have to collect together in one spot to achieve it. And the fundamental regime we're imagining here is a society of creatures who exist in space-time at different places, but then near each other in order to exchange and to interact with each other. And then the constraint on interstellar colonization is a constraint on anyone creating a device, which is basically a starship, and then sending it out into space. And that device having sufficient resources and structures to successfully travel a long distance and colonize. So the limitation on interstellar colonization would have to be a limitation on looking at each place in the civilization and seeing what kind of machines they've built and what those machines are capable of in order to say, oh, okay, that's not a starship, or that's not part of a starship, so that's okay, right? So as technology develops, there becomes a larger space of kinds of machines that could exist and people could make. So your task of checking all the machines to see whether any one of them is a starship gets a bit harder. But if starships are just pretty unusual machines that are, on unusual scale and kind of materials they would have and place they would be, then it may not be that hard to check that things aren't starships. You might say, well, my toaster could be a starship. How do you know? Well, I think we might know. We could, the question is how much we'll need to monitor. So I guess, we're early in the technology of social monitoring. So as you may know, a century ago, a number of totalitarian regimes appeared where governments tried to have a relatively total view of the society and a relatively total control of the society. And they overreached substantially. That is, they were not able to effectively exercise the level of control they had acquired for themselves, they did actually have pretty good monitoring. I think the failures of the totalitarian societies were not failure to monitor or survey sufficiently. I think they were failures to actually use the resources effectively and to manage their organization effectively. So now over time, we are slowly getting better at organizing and managing and at surveillance. So it seems to me the trend so far has been to make it easier to look for deviations of people with a kind of machine they aren't supposed to have, doing a kind of thing they're not supposed to be doing. For better or worse, that seems to be getting easier lately. So I'm not seeing a problem with this scenario, at least in terms of recent trends. Now it could be that some new physics technology appears that suddenly makes it much harder to do the sort of monitoring that we're talking about. So, for example, if you can make a tiny little pocket universe that, has only a tiny entrance, but a huge interior volume that you could hide secret starships in, well, then you could have some secret starship building activity inside this volume that people couldn't see, and then that would be more of a problem for the monitoring, right? But that seems pretty unlikely to me at the moment. Seems to me, however you're going to be building starships for the near future, they're going to take a physical volume and they're going to take familiar materials and they're going to need a lot of negentropy, and we just track those things. We're going to find your starship.
Awesome. Well, this has been a fascinating conversation, Dr. Hanson. Appreciate you taking the time. Before we sign off, what's the best place to follow your work?
Well, I have a website, hanson.gmu.edu. You can just Google my name, Robin Hanson, and find many other places. I'm on Twitter. And I have 2 books, The Elephant in the Brain, Hidden Motives in Everyday Life, and then another book, The Age of M, Work, Love, and Life, When Robots Rule the Earth. You can look for those, but, again, searching for my name, we'll find most of it.
Well, excellent. Thanks again, and hope to chat about these topics again sometime soon.
All right. Thanks for inviting me. Bye.